Hello, everyone. Welcome to the course on reinforcement detailing in plan. This is a beam reinforcement detailing drawing that shows an example of how to annotate the beam reinforcement plan. The plan annotation method is applied on the beam layout plan, selecting one beam from each group of beams with different numbered beams. On each selected beam, annotate the section dimensions and reinforcement details. To represent the beam reinforcement detailing drawing, plan annotations include centralized annotation and in situ annotation. In this lesson, we will study the content of centralized annotation for beam members. Centralized annotation includes 5 mandatory items and 1 optional item. Centralized annotation can be extended from any span of the beam. The specific rules are as follows. The first mandatory item is the beam number. Beam numbers include the type code, serial number, span count, and cantilever information. They should comply with the specifications in Table 5:1. As shown in the table, Arabic numerals are typically used for serial numbers. A indicates a cantilever at one end, while B indicates cantilevers at both ends. Note that cantilevers are not included in the number of spans. The second mandatory item is the beam cross-section dimensions. For constant section beams, use B by H to indicate the size. For beams with vertical haunches, use B by H, YC1 by C2 to indicate, where C1 is the haunch length and C2 is the haunch height. For beams with horizontal haunches, use B by H, PYC1 by C2 when haunching is only on one side, where C1 is the haunch length and C2 is the haunch width. Haunch locations should be illustrated in the plan drawing. When the beam is cantilevered, and the height at the root and the end differ, use a slash to separate the root and end heights, that is, B by H1 / H2. The third mandatory item is the beam stirrups. Details of beam stirrups are shown in Figure 5:1, including rebar grade, diameter, spacing in densely and sparsely spaced zones, and number of legs. Use a slash to separate the spacing and leg count in densely and sparsely spaced zones. If stirrups have the same spacing and leg count throughout, then no slash is used. If the stirrups have the same number of legs in both zones, then write the leg count only once. The number of legs should be placed in parentheses. For example, Phi 10 at 100/200 means that the stirrup is HPB 300 grade rebar with a diameter of 10 mm, spacing 100 mm in densely spaced zones, 200 mm in sparsely spaced zones, and 4-leg stirrups throughout. Now, take a look at Phi 8 at 100/152. This means the stirrup is HBB 300 grade steel, with a diameter of 8 mm, spacing 100 mm and 4 legs in densely spaced zones, and 150 mm with 2 legs in sparsely spaced zones. The fourth mandatory item is the configuration of continuous top longitudinal reinforcement or erection rebars. Continuous longitudinal reinforcement is load-bearing reinforcement, mainly used in seismic frame beams, or in continuous beams of non-frame structures where required by the designer. The rebars may have the same or different diameters, and may be spliced, mechanically connected, or welded. Erection rebars are a type of structural reinforcement used to facilitate tying of stirrups. Erection rebars are not considered load-bearing in calculations. They are generally placed in compression zones of beams and have smaller diameters. Continuous longitudinal rebars are placed at both the top and bottom of the beam. Erection rebars are only placed on the top of the beam. When both longitudinal and erection rebars are in the same row, use a plus sign to connect them. Place the corner rebar before the plus sign, and the erection rebars in parentheses after the plus sign, to distinguish it from the longitudinal rebar. If only longitudinal rebars are used on the top, note the longitudinal rebars directly. If only erection rebars are used, they should be placed directly in parentheses. The fifth mandatory item is the configuration of longitudinal structural or torsional reinforcement on the beam sides. When the web height HW of a beam is greater than or equal to 450 mm, longitudinal structural reinforcement should be provided, and the specified type and quantity shall comply with relevant design codes. This item should be annotated starting with the capital letter G. When the beam is subjected to torsion, the annotation should begin with the capital letter N, followed by the total amount of reinforcement on both sides of the beam, arranged symmetrically. Torsional longitudinal reinforcement shall meet the spacing requirements for side longitudinal structural reinforcement, and no additional longitudinal structural reinforcement is required. The lap length and anchorage length of structural reinforcement can be taken as 15 times the bar diameter. The sixth item is an optional annotation, relative beam top elevation. Relative beam top elevation refers to the height difference relative to the structural floor elevation. If a height difference exists, it should be written in parentheses. If there is no height difference, it may be omitted. When the beam top surface is higher than the structural floor elevation, the elevation difference is taken as a positive value. Otherwise, it is negative. For torsional longitudinal rebar, the lap length is denoted as LL or LE, and the anchorage length is denoted as LA or LAE. Well, that concludes the 5 mandatory and 1 optional centralized annotation items for beam members in plan drawing. Have you mastered them?